And hi, right away, apology. I'm not an official trainer. These are not official courses during learning mode and the learning mode zone. So I'm just sharing, blogging my learning process for the Godot and Blender. I'm anybody curious trying to learn from the learning materials that are available online, and I recently prefer more text format to follow. I just bring one Godot in, which is 4.3 before I do anything. And for Godot, well, this was a random pick at the moment. Logic preferences. I skipped notification interfaces, data preferences. But let's have a look. Step back into data preferences. It is an abstract, probably material, more like how to structure how to take in considerations for game design, for data preferences for in the game, in the project. Ever wondered whether one should approach problem X or data preferences? Okay, imagine a note. Imagine if one had to process 3 million data points with a single frame. Within a single frame, it would be impossible to craft a feature with a linear time algorithm, since the sheer size of data will increase at the runtime far beyond the time allotted. So, okay, so array versus dictionary versus object. Godot stores all variables in the scripting API in the variant class. Variant can store variant compatible data structures as array and dictionary. So I just read through this part to determine what's the subject. And it's good to know for future reference to go through this, to see what would be better to optimize performance with data preferences in mind. That was array versus dictionaries versus objects. Then we have similar idea about whether, oh, that's in the same page, enumerations, integers versus strings, enum types, animated texture versus animated sprite 2D versus animation player versus animation tree. Okay, this is more use case focused, narrow scope to choose from. Under what circumstances should one use each of Godot's animation classes? The answer may not be immediately clear to new Godot user. That's true. I'm curious about that. Animated texture is a texture that the engine draws an animated loop rather than a static image users can manipulate. Animated texture, okay. First, the rate at which it moves across each section of the texture, frames per second. The number of regions contained within the texture frames. So if I actually now jump into this project, let me have for a reference what was we used here a sprite sheet for the player 2D, and if I change here to inspector, we have a sprite Okay, this is sprite, an animated sprite. Okay. So if I set this, if I go back to the article, second, the number of regions contained within the texture frames. Godot's rendering server then draws the regions in sequence at the prescribed rate. The good news is that this involves no extra logic on the part of the engine. The bad news is that users have very little control. Also know that animated texture is a resource unlike the other node objects discussed here. One might create a sprite 2D node that uses animated texture as a texture, or something the others can do. One could add animated texture as tiles in a tile set. So this is what I wanted to check actually, because we had I remember that for this sprite 2D, a texture was applied, an image file with 3 frames, like a sprite sheet. And let's go, what's going on next here. So note that the animated texture is a resource. One might create a sprite 2D node that uses animated texture. That's this case for this example, a classic shoot 'em up. For many auto-animating backgrounds that all render in a single batched draw call. Okay, that is what one could do with animated texture. Okay. The animated sprite 2D node in combination with the sprite frames resource allows one to create a variety of animation sequences through sprite sheets, flit between animations and control their speed, region, offset and orientation. This makes them well suited for controlling 2D frame-based animations. If one needs to trigger other effects, I want to quickly check what is this here. Animated 2D sprite. So the ship, the animated 2D sprite, has animation. This is just the booster. So 2 different things applied here. Okay. The ship itself has 3 frames, but they are not animated like with animation player. The frames for the ship are changed by the user input, but the animation player has is there animation sheets, shader editor sprites is using animation frames as a sprite sheet because this is that's property of the animated sprite 2D. And if I click ship, does it have animation? No, not in that sense. So even that the animation is here, still this animated sprite 2D it creates animation with sprite frames. So animation. If I click sprite frames, I still see here what are the animations created. but I guess the selected here method and resource new sprite frames. So as I added a for animated sprite 2D, selected the animation section and created new sprite frames, the section for sprite frames is available here to implement that. Do I have animation for, let's say, enemy? Do they have animations? Sprite 2D. Where are theirs? Where are the okay, they use the animation player. So enemy ships use animation player. Probably because it provides more complexity here. Not the reset. So, and here are the created animations. Here is the list, drop down with the list of animations, and that's exactly how they look in the runtime. Okay, so good thing is I have this, I can do this side-by-side comparison inspection and follow through the manual, as I have actually, I'm familiar with that implementation now, and I can do analysis what I've actually implemented and for what reason. Because the tutorials often just give you the recipe and here you go, that's it, you did it. But why did I do it that way? Now I guess this is the post-mortem for the tutorial. Just like I did it, I just went through and inspected my finished projects for tutorial and compared here with the manual. To clarify why one case, why the other case for animation sprite sheets versus animated sprite 2D and actual animation player. So here it says, if one needs to trigger other effects in relation to animation changes, for example, create particle effects, call functions, or manipulate other peripheral elements beside the frame-based animation, then one will need to use an animation player node in conjunction with the animated sprite 2D. Animation players are also the tool one will need to use if they wish to design more complex 2D animation systems, such as cut-out animations, editing sprites transforms at runtime, 2D mesh animations, defining a region for the sprite's texture and rigging a skeleton. Okay, cool. Then one animates the bones which stretch and bend the texture in proportion to the bones, the relationships to each other. Okay. A mix of the above. While one needs the animation player to design each of the individual animation sequences for a game, it can also be useful to combine animations for blending, enabling smooth transitions. Okay. There may also be hierarchical structure between animations that one plans out for their object. These are the cases where the animation tree shines. One can find an in-depth guide on using the animation tree here. Let me check. Well, let's see that animation guide. Amazing. Video tutorials where using animation tree, is this that guide? So Okay, that's the section of the manual. Okay, okay. Data preferences, logic preferences, so loading versus preloading, large levels versus static versus dynamic, project organization. Going kind of quickly through this, getting familiar with the manual, that's good. Since Godot has no restrictions on project structure or file system usage, organizing files when learning the engine can seem challenging, this tutorial suggests a workflow which should be a good starting point. We will also cover using version control with Godot. Okay. What was I about to... Something crossed my mind. Did I maybe go too fast? Well, just to make sure, what are the notifications and few more bits that I've skipped. Every object in Godot implements a notification method. Its purpose is to allow the object to respond to a variety of engine level callbacks. So those notifications, okay. Enter tree, ready, exit tree, process delta. Okay, okay. So these are called notifications. This is important. What users might not realize is that notifications exist for types other than nodes alone. Okay. Process versus physics, process versus input. Use process when one needs a frame rate dependent delta time between frames. If code that updates object data needs to update as often as possible. Let's see, then use physics process when one needs a frame rate independent delta between frames. If code needs consistent updates over time, regardless of how fast or slow time advances. This is the right place. Physics process, that's like real time. So kinematic and object transform operation should execute here. While it is possible to achieve the best performance, one should avoid making input checks during these callbacks. Process and physics process will trigger at every opportunity. They do not rest by default. In contrast, input callbacks will trigger only on frames in which the engine has actually detected the input. One can check for input actions within the input callbacks just the same. If one wants to use delta time, one can fetch it from the related delta time methods as needed. Call during every input event. Is there a delta? Oh, okay, get process delta time. Okay, that's the way how to grab the delta time. And process delta is receives the delta on each call. Underscore init versus initialization versus export. If the script initializes its own node subtree without a scene, that code should execute in init. I almost skipped these most important bits, and they're not too big articles. Other property or scene tree independent initialization should also run here. Other property or C3 independent initialization. Okay. Underscore init triggers before enter tree or ready. Okay, but after a script creates and initializes its properties, When instantiating a scene, property values will set up according to the following sequence. Initial value assignment. Okay, now that is, I'll skip it. Test is initialized to 1 without triggering the setter. Okay, here we have example of implementation in the shoot 'em up game. When this was with this statement implementation for that project, we got the this example: exported value assignment. An exported property value is again replaced by any value set the inspector, triggering the setter. Okay, that was the trick over there happening. So export value, this variable is available now with the export statement in the inspector user interface of the engine editor. String equal 1 and set value test equal value plus exclamation. So an exported property value is again replaced by any value set in the inspector, triggering the setter. So set value test equal value. And where is the value? What's the value? Set value. Okay, this is the test equal to triggers the setter, changing test's value from 1 to 2. Okay, this is good to know because it's very weird. Initial value assignment. The property is assigned its initialization value or its default value if one is not specified. If a setter exists, it is not used. Underscore init assignment. The property's value is replaced by any assignment made in init, triggering the setter. Okay, I think I get it. So they say init triggers before enter or ready, but after a script creates and initializes its properties. So this is executed before, and it says if someone sets test to 3 from the inspector, it will trigger the setter, changing the test's value from 2 to 3. Triggers the setter, changing test's value from 1 to 2. So here is the initialized value, and this will be a setter triggering, and setter receives a value passed, and it is actually a function, setter function, test equal value plus. Oh, okay, so I think I understand now. So this is the expression for the members setter methods. So this will be a member with the initialization and with a column expression written this way. It means, okay, this member has a setter method. I think I understand it now, because it wasn't clear. It was not explained in the here in the shoot 'em up tutorial. It was just code given right there and without any explanation. Why can't I need to go to this thing. Hey, at least like this. So where was it, who was it? Enemy? Bullet? Who had the setter function? Main. Was it in main? No. Enemy. Player. Ready. Process shield. Ready. Not even the player, maybe the main. Did I get it in main? No. UI? No. So where was this in this example? Which script had this implementation? So to fix to get the finally working tutorial project, I fixed my issue with breaking, arranging these nodes in a different way in the main scenes node tree. So I had the player first, and that would break. And looking at the debugger, the steps, the code execution steps, I figured out, okay, something is happening before initialization of something else. So I've figured out, okay, if I try to change the order in a tree, will that fix it? And that is true. You need to consider for the initialization and processes how the events are and notifications sent and steps get executed in runtime. You need also to pay respect and detail to your node tree structure, because it's a top-down hierarchy, whether it's execution or whatever logic applies on it, whatever use case and rule set, whether it's for execution or some other method that it goes into process, whatever process. So let me see, can I find the scripts? Not the documentation. It's not this. Score counter. No. Player. Main GD. Was it the main GD? Or I'm just blind? Or I'm just blind right now? Enemy? I'm certain that here was in one script that setter. It's only a question whether it is on top or below. Did I miss any? Are there any other scripts? Close the resource pack. Bullet GD. Enemy GD, open it. Double click enemy bullet. The main GD, open it. Player open that. The score counter, open it, and this one. So if I try to look through it, can't see it. I really want to now find it and have a look at it, see if I can break it down, understand it. Okay, here it is. It's the shield. It's the freaking shield. Shield equal max shield with a setter method set equals set shield. And where is the set shield? Set shield. Here it is. And this was giving me issues, whether it by execution order or this initialization from the code. So what was this? What was that set shield for a player? This is player script. Player script. Oh, where is this? Okay, here it is. So this should be like this, with this together. Oh, so it's a little bit different. Here we have a test variable with a setter method, while here we have a variable and another variable that is assigned to a max shield. No, wait, okay, the shield has assignment to max shield. What is this? Can I have... Okay, the link jumps to the first definition occurrence of the max shield. If I click Control left click, so this is a set shield for the shield. Okay. And what does this hint? Does this hint like a type hinting or initialize to this? What does this example give me? Because here we have, this is a type hint for the test variable. Just a little bit different, but almost doing the same thing. So that would be this section. Rediverse center 3. Okay, rediverse center 3. Instantiate scene, init, ready, and so on. That's good to know. What comes first in the order of execution? The inbuilt methods. Logic preferences, we're talking about nodes, loading, preloading, level, static, project. Okay, project organization. And for project organization, style guide, I will just have a overview of this. Okay, I will close this section, take a short break, and for the next section I will go try and take some of the recipes from Kids Can Code, and then I will choose whether something from Godot version 3 or 4. I will compare the recipes just for the I don't know, maybe exercise both versions. There are still version 3.6 still viable. It has a great user base and extensions available all around. So short break, hitting the mark. Here goes the outro. Mali ready here, your host who loves you the most, even you. Not forgetting about you. Stay safe.